All right, so I've got this video I'm going to make here. Here's the recap of what we did in class today. There we go. We had our exponential trend line that we made here in pink. We did the predicted column, the actual minus predicted column in order to do our residual plot, comparing season number to the actual minus predicted values. And we made our residual plot for exponential. So I am going to do a Quartic regression now with the data. So again, to get this new page, you can just copy and paste columns A, B, and C from the original tab over to here. And I'm going to run a Quartic regression. Again, we want to compare the season number to the 3-point attempts made. So just like we did in class, we're highlighting all of this data and we are inserting a chart. I'm not going to be pausing as much as I was in class because you can pause the video yourself if I'm going too quickly. And you can rewatch sections as needed. So we get our scatter chart, scatter plot of the data. And once again, we double click on the data points. If it accidentally takes you to here, you can go back to customize. And in the customize tab, you can select your trend line. Now I'm going to be doing a Quartic trend line, so that means I need polynomial degree 4. That's Quartic. And so there we see our Quartic trend line. And based on the eyeball test, it appears to be a better fit than the exponential was, which is why I'm choosing it. If I look at the r squared, that's definitely better than the exponential r squared, 0.891 compared to 0.94. So this is 94% accurate at relating 3-point attempts to the season number compared to exponential, which was 89.1% accurate. So this is better. And also I need to, in that window, so if you get lost and you got to get back to it, you go to customize, go to series, or you can just double click on the dots again. And I need to make sure that I get a custom label. Instead of custom label, I want to use the equation as the label. So you can see this is a Quartic equation, and what makes it Quartic is the x to the 4th power at the end there. It turns out that Google Sheets writes it in reverse order rather than in standard form, but we'll be able to work with that. And again, if I want to make some changes, I could make my trend line pink just to stay consistent, make it a little thicker so I can see it better. I don't want those. All right, so I've got my Quartic trend line. And if you'll remember, we had to slide the chart over so that we can add the actual and actual minus predicted. I mean, the predicted and then the actual minus predicted columns. And in order for me to be able to see this chart, I'm just going to bring it up as I go. So predicted, again, we want to make, and then actual minus predicted. Predict. So this one's going to be a little more complicated formula. It starts off the same. I type my equal symbol to let Google Sheets know that I'm going to be typing a formula. And I'm just following that formula there on the chart. So 4,371 plus negative, so I can just put minus 1,076 times x. What is x? X is the season number. In this case, this row is season number 1. So I click on B2. So that takes care of the 4,371 minus 1,076 times x plus 309 times x squared. So this time I do b2 to the 2nd power, and then minus 12.6 times b2 to the 3rd power plus 0.165 times b2 to the 4th power. In this equation, I took the equation from the trend line, from the chart. I replaced x with b2 every time. That's all I really did. And that's going to get me my prediction for season 1. And it may suggest this autofill, which is fine. If it doesn't, you can click on the cell, click on this blue box right here, and drag it down. And you'll know immediately if you did something wrong because you're going to get some wonky values. I can tell I did it correctly. Even still, I'm getting my later predictions are off by 77,529, which is massive. So it's doing pretty good mostly throughout the function, but there's some points here at the end where it's off by a massive amount compared to what it was. Sorry, that's not how much it's off. I was comparing column to column. To see how much it was off by, we need to do the actual minus predicted column. So equals the actual 3-point attempts in that season minus the predicted 3-point attempts in that season. And it may autofill for you. You can accept that, or you can click on the middle of the cell, get this blue box, and drag down. And now I can see, so off by 15,000 there at the end. Off by 4,000 here in the middle. So not doing too bad. But let's get this residual plot so that we can compare. So remember, to get the residual plot, I add another sheet, call this Quartic Residual. And into this sheet, I need to copy and paste the season number, column B. So I copy that. And then I need to get the actual minus predicted column, column E. And when I paste this one, I have to do the right-click special paste values only. Then I insert my chart, so highlight all the cells, insert chart, and that's my residual plot. So now we can compare this residual plot. How close are these points to the x-axis versus the exponential residual plot? And you can see there's a lot of similarities, but on the whole, this Quartic residual plot shows that these predictions are much closer to the x-axis in general than the exponential residuals were. So Quartic appears to be a better fit based on the residual plot. It appears to be a better fit based on the r-squared value of 0.94 compared to the exponential r-squared value of 0.891. Again, this r-squared value here is closer to 1. And so now that you have all of this, you can turn in this file and you're done with the work for the asynchronous day.